So for number 12, we want to assign a grade to these proofs. We want to assign the grade of A if it's correct, C if it's partially correct, if the idea is in the right place, but we just need to correct a few items, and F if it does not get even close to proving what we need to prove. So for A, the claim is that if m squared is odd, then m is odd. Right? So now they're saying, okay, assume that m squared is not odd. Well, if we're trying to prove if P implies Q, the other way to prove it would be if not Q implies not P, right? These are logically equivalent. However, he's trying to say, okay, if P implies Q, and then saying, okay, assume not P, and then he wants to show that M must be even. So he wants to show that it leads to not Q. However, these are not equivalent. This is the conditional, and this is the inverse, which is equivalent to the converse, right? So the argument itself is well argued. However, it begins completely wrong because it begins by assuming not P. And we either want to assume P and show that it leads to Q, or we want to assume not Q and show that it leads to not P. So this one has the reasoning completely backwards, and so it cannot prove what it needs to prove. So this one we are going to give an F, because we want to show if Q, then P. So you would begin if not Q, we would begin if not Q. But we can see that this is actually not the case because they're saying if not P. So that does not work. Okay, now let's do item B. If T is irrational, then 5T is irrational. So now they're doing the contrapositive, right? They're trying to show if P implies Q, and then they're going if not Q, and then show that it leads to not P. So we have here 5T is irrational, so they're supposing not Q, and that would be our P. So if 5T is rational, then 5T is equal to one integer over another, P over Q, where Q is not equal to 0, so that is correct. So therefore T, they divide everything by 5, is equal to P over 5Q, where P and 5Q are both integers, and 5Q is not equal to 0, so T is rational. It does show that, hey, if not Q, then not P. Therefore, if P, then Q. So this does work perfectly, so we give it a grade of A. Okay, let's do item C. So item C, they're trying to prove that if X and Y are even, then X plus Y is even. And they're trying to do it by contradiction. So they're saying, suppose that X and Y are even, but X plus Y is odd. So they're assuming the opposite, and then they're showing that it leads to a contradiction. Then for some integer k, x plus y is equal to 2k plus 1. Okay, we're good until here. Therefore, x plus y minus 2k is equal to 1. Okay, we're good. And then it says the left-hand side of the equation is even, because it is the sum of two even numbers. But he can't say this because he actually said, suppose that x plus y is odd. So you can't say suppose x plus y is odd and then have that x plus y is even. The whole thing that he's trying to prove is that x plus y is even. So he's already using what he's trying to prove as a reasoning to get to where he wants to prove. So this is circular and doesn't go anywhere. So we're going to say that this one fails because it assumes what it wants to prove. And let's do D. So it says, if A divides both B and C, then A divides B plus C. So that's what we want to prove. And then it's going, okay, assume that A does not divide B plus C. So it is assuming, it's beginning by assuming not Q, right? So we should expect that this leads to not P because the contrapositive is logically equivalent to the conditional. So then there is no integer k such that AK is equal to B plus C. Then it says, however, A divides B. But this is an issue because we don't know this, right? It doesn't say assume A divides B. Because now we have here that what he's actually trying to do is by contradiction. So he wanted to do assume A divides B and suppose that A does not divide B plus C. However, he didn't state that assumption. So we don't know that A divides B. So that would be AM is equal to B for an integer M, and A divides C. Once more, we don't know this because he never said assume, right? He never said that. So we don't know this. So even though the reasoning is correct, how you would do it by contradiction, because then you'd show that it leads to a contradiction, and so the assumption must have been false. Even though this is correct, he did not state the assumption, so we cannot know whether this statement here and the statement here is true. So I'm going to give this a grade of C, because with just these minor tweaks, we could make this correct.